In the last session, we have completed about displacement position of a particle in SHM. Just we have completed as this position of a particle, position of a particle in SHM. What is the formula? X is equals to A sin omega t, X is equals to A cos omega t. Both we can write. This is what starts from mean position. So this is starts from mean position. This is starts from where? Extreme position. Starts from extreme position. This is first one. And next one, velocity of center of mass. Velocity of center of mass. So velocity of center of mass of a particle, okay, of a particle in SHM. So we have written that V is equals to A omega cos omega t. Okay, so V is equals to omega under root of A square minus X square. This is called time dependent. Time dependent. Okay, time dependent as a function. At t is equals to 0.5 seconds. What will be the velocity? At t equal to 1 second, at t equal to 2 seconds. Then we can use this. And so V is equals to, this is what you say, it's a position dependent. Position dependent. Position dependent. Okay, is the case. So this is about position of a particle in SHM. Position of a particle in SHM is the relation. Okay, and velocity of a particle in SHM, this is what is the condition for, like we can take it as velocity of a particle in SHM. Position dependent, position independent. Now, next, what is the acceleration of a particle in SHM? Acceleration is, this is what the rate of change of velocity. Rate of change of velocity, just the rate of change in velocity. The rate of change in velocity is what? Acceleration. Okay, so the rate of change in velocity is called acceleration. So the time rate of change, we can also say as the time rate of change in velocity at an instant, at a particular time, at an instant. Also we can say it's what? Acceleration. Okay, so the acceleration of the particle in SHM, time rate for the both the cases we can use. So how do you get this velocity? So after the differentiation of position. How do you get the acceleration? After the differentiation of what? Velocity. Okay, so for acceleration, A is equals to dv by dt. We know this. A is equals to dv by dt. So A is equals to, what is the V? V is equals to A omega cos omega t. So is the formula. This is time dependent or position dependent. It's a time dependent. You are doing with respect to time, we need to use this one. With respect to position, if we talk about, we need to go for omega under root of A square minus X square. Okay, so if we use this, the here acceleration A is equals to d by dt times of, what is the V? A omega cos omega t. A is equals to A omega as it is. Differentiation of cos theta. Differentiation of cos theta with respect to time. What do you say? Minus sin theta minus sin omega t. Minus sin omega t. Again differentiation of this omega t. What do you say this? Omega. It's a omega. So what is the formula for acceleration? A is equals to minus a omega square sine omega t is the relation for acceleration. Yes, so acceleration is the just what the rate of change in velocity or the time rate of change in velocity at any instant is called what you say, it's a acceleration. Acceleration A is equals to minus a omega square sine omega t. So what is the acceleration? A is equals to minus a omega square sine omega t is the acceleration. Okay, so acceleration of the particle in what? SHM. So what do you say? This is what it's a time dependent function, time dependent form of SHO, simple harmonic oscillator. If you write this from here, this is what A is equals to minus omega square as this. Then what do you say? A sine omega t. So what is this? It's a position. Correct? Position of a particle in SHM. What is that? A sine omega t. A is equals to minus omega square x. So this is called what? Position dependent form. Okay, so it's a position dependent form. So position dependent form of SHO, simple harmonic oscillator. Yes, so I got the acceleration A. Okay, it's a with respect to as a function of t, as a function of what? It's a position. So if you then I want to know about where it is maximum, where it is minimum. Next one, what is the graphical representation, right? So first one is about, I want to know about, for the first case, at mean position. Okay, at mean position. My mean position means what? X is equals to what? 0. Correct? At x is equals to 0. Yes, at x is equals to 0, A is equals to minus omega square 0. A is equals to what you say? 0. Where is that? At mean position. At mean position, acceleration is maximum or minimum? It's a minimum. This is what? Minimum. Correct? Okay. So acceleration is minimum. What is that minimum? It's a 0. Okay. So next I am talking about at extreme position. At extreme position. Yes. So at extreme position, if you speak about extreme position means what? X is equals to what? A. X is equals to A means what? A is equals to what you say? Minus omega square x. A is equals to minus omega square A. So for better understanding, we can write from now onwards plus or minus omega square A. Acceleration of particle in SHO plus or minus omega square A. Maximum one. Sir, how do you take? This is the linear oscillation, for example. Yes. So it's what? X is equals to 0, x is equals to A, x is equals to minus A. Say x is equals to plus A, x equal to 0. This is what, ma? So plus or minus omega square A. Minus means what? Left side. Plus means what? Right side. You don't say it's a negative value and positive value. Only it shows it's a left or right from the mean position. Okay. So this I can say minus omega square A. It's what? Plus omega square A. Minus and plus. Right. So this is at extreme position. Means what? Where it is maximum and where this is minimum. Okay. So next I am going to prove this one. So what is the formula for acceleration? Acceleration A is equals to time dependent function I am taking as minus, what is the formula? Minus A omega square sine omega t. Correct? This is the condition. Let me know a t is equals to 0, t is equals to t by 4, t is equals to t by 2, t is equals to 3t by 4, t is equals to t. 4 cases, let us do then. Then graphically where it is possible, let us see this is. Okay. So we got it to understand it's what maximum acceleration is what? A omega square. Okay. So for the first one is about t is equals to, at t is equals to 0. Okay. At t is equals to 0. At t equal to 0, so a is equals to, what do you say now? Minus a omega square sine omega times of 0, acceleration a is equals to 0. First one completed. Okay. So at t is equals to t by 4. Okay. So then what? A is equals to, what do you say? Minus a omega square sine omega means what? 2 pi by t into small t is what? T by 4. Correct? T by 4. So then what? It's a t and t cancel. 2 ones to 2's. Pi by 2, 90. Sin 90 value 1. So what we do now? A is equals to minus a omega square. Minus a omega square. Minus means what? It comes down. Okay. So this is what? Next. T is equals to, at t is equals to, what do you say? It's a t by 2. Now we can try for this is what? A is equals to minus a omega square sine. Omega means what? 2 pi by t into small t is what? T by 2. T cancel. 2 cancel. Sine pi 0. Sin pi is what? 0. Sin pi, 2 pi, 3 pi, 4 pi. All these will be what? 0. Cos pi, cos 180 is what? Minus 1. Okay. So, you remember it's a sine pi is equals to what? 0. Cos pi is equals to what? Minus 1. Okay. Is the case. Now, A is equals to minus a omega square. Sorry. It's what? 0 now perfectly. Then A is equals to what do you say? It's a 0. Yes. Next. So first one we have completed for t is equals to 0. Next one t is equals to t by 4. Next t is equals to what do you say? It's a t by 2. Let us check this one. T is equals to, I am using about 3t by 4. Now try it. T is equals to 3t by 4. Okay. So for this a is equals to now minus a omega square sine omega t 2 pi by t into what? 3t by 4. Okay. T and t cancel. 2 ones to 2's. Then a is equals to minus a omega square sine, what is this? 3 pi by 2. Pi by 2, 90. 9 3s are 27. Means what? 270. Sin 270 value. 180 plus 90. 180 plus 90 is which quadrant? Third quadrant. Okay. So sin 90. Sin 90 is what? 1. Third quadrant means what? Minus. So this a is equals to, you can write it as minus of minus 1. What is the answer? Sorry. So it's what? A omega square only now. Okay. Minus of minus 1 times of minus and minus 1 times of. So then what? A omega square. What is the answer? A omega square. Yes. So next one here t is equals to, then what? Next one t is equals to, what is the t equal to? Capital T. Capital T means what? You are getting 0. Yes. How is this? Okay. Now we check about x is equals to, this is what? X is equals a is equals to minus a omega square sine omega t. A is equals to minus a omega square sine omega means what? 2 pi by capital T. Next one t. T cancel. Sin pi, sin 2 pi, sin 3 pi, sin 4 pi, all will be 0. So what is the answer? A is equals to 0 is the relation. Now let us draw the graph. Okay. So first one here, just to take about, it's a x and y axis like. Okay. So this is what? positive and negative. Okay, so four means what? One wave to be completed. Like carefully. Yes. Next one. So this is what maximum value I'm taking this. It's a maximum. Yes, either sides I'm writing this. Now, so this is what acceleration. This is what time. What is your source? The source is what? A is equals to minus A omega square sine omega t. What is the maximum value at this point? Maximum value what? A omega square. At this point, minus A omega square. At t is equals to 0, what is your answer? 0. Correct? Next. At t is equals to, this is what? It's a t by 4. This is what? T by 2. This is what? 3t by 4. This is what? It's a t. At t is equals to t by 4. At t equal to t by 4, what do you got? Minus a omega square, correct? Minus a omega square. At t is equals to t by 2, what do you got? This. Next one is what? This. Next one is what? This. Check from your values. So, just I'm writing, at t is equals to 0, what is the acceleration? 0. At t is equals to t by 4, what do you got, ma? A is equals to minus a omega square. At t is equals to t by 2. A is equals to 0. At t is equals to 3t by 4. A is equals to a omega square. At t is equals to t. A is equals to 0. I am using these values. Yes. Now your graph is what? Starts from here. This is what? Like. Is it okay? Same the condition, x is equals to a sine omega t. How you got the graph? It is like reverse. Correct? Okay. So this is the condition for this. T is equals to, now what is the maximum amplitude either sides? This is first one, a omega square. This one is what? Minus a omega square. Now one more, the question is about draw the graph between acceleration versus position. Acceleration versus position graph. What is the graph between acceleration versus position? Acceleration, what is the position is taking that? What is the formula for acceleration as a function of position? A is equals to, what is the formula? A is equals to minus omega square x. A is proportional to what? X. Correct? No. It's what? The graph should be what? Graph should be straight line. It should be straight line. Okay. So then if you draw the graph from this, correct? Okay. So it is like a y is equals to, we can say y is equals to mx negative slope. Y along with y axis, what is there? A. Along with x axis, what is here? X. It's a straight line passing through origin, negative slope. Angle is what? More than 90 degrees. Theta is what you say? It's a greater than 90 degrees. Slope is what? Negative. Negative slope. Yes. So what's your answer? This is what? A proportional to minus x. Correct? So A is equals to minus omega square x. A proportional to what? Minus x. The graph should be like this. Okay. So it can give it as the maximum values for this. This is, for example, if you take about its coordinates. So what is this value here? Omega square A. A amplitude left side minus. Okay. Next one. This is what? Okay. Then what do you say? Yeah. From this, if I talk on this, is what? It's a Correct? This is what A only, no? Next one is what? Omega square A. It's what? Minus omega square A. Okay? So this is the graph like, so A is equals to minus omega square X. Okay. So next one, as the same thing, the question may be asking like force, restoring force. This is the condition for acceleration. You may get the question like, so draw the graph between that restoring force and position. So what is the formula for restoring force? Restoring force. F is equals to minus kx. Correct na? Yes. F is equals to, what do you have? F is equals to m into A. F is equals to m into A means what? Minus omega square x. F is equals to minus m omega square x. K means what? What is the K? M omega square. K is equals to m omega square. Now you see this. You remember this K is what? M omega square. So now we can go for the graph again. Same thing. What is the condition? Y is equals to mx. Mx. Correct? Okay? Negative slope. Same the situation like x and y axis I am taking as this. Along with y axis, y means what? F, restoring force. Along with x axis, this is x minus x. Okay? So the graph should be what? Like this, na? Correct? Now if you want to write its coordinates, the coordinates are what? Like along with x axis A. Okay? So this is what? Minus A. What is the maximum force from this? F is equals to minus m omega square x. Okay? Minus m omega square x. So in place of x, if I substitute A, what is that? So what is this condition? M omega square A. This is what? Minus m omega square A is the relation. So graph between restoring force versus position, graph between acceleration versus what? Position, like a similar graphs, right? An object performs SHM. An object performs SHM. Its amplitude is which is what? A. Amplitude is what? It's a 5 centimeter. And time period, it's a 4 seconds. One oscillation can be completed by 4 seconds. And if the object is started from mean position means what? X is equals to 0. From this is the information we have. Calculate. Okay, calculate. First one by one you can take about. First, calculate frequency of oscillation. Calculate frequency of oscillation. Second, displacement at t is equals to 0.5 seconds. Displacement and at t equal to 0.5 second. And next one, maximum acceleration. Fourth one, velocity. So velocity as a function of position, as a function of time. Okay, So for example, I'm talking about as a function of position at 3 centimeter from mean position. Okay, from mean position is the case. An object performs SHM. Amplitude given. Okay, it's what? It's amplitude mentioned. Now the amplitude is what? Here, first one A is equals to 5 centimeter. Time period T is equals to 4 centimeter. So then first one I'm talking about this frequency. Okay, frequency. How do you get the frequency? F, reciprocal of time period. Reciprocal of time period means what? 1 by 4, 0.25 seconds. First one is over. For the second one, displacement at t is equals to 0.5 seconds. X is equals to formula A sin omega t. Correct. Starting from mean position, x is equals to A sin omega t. If it starts from the extreme position, x equal to A cos omega t. Okay. This x is equals to A. What is the A? First amplitude 5. It must be in centimeter. Sin omega. What is omega? 2 pi by t into what? T. Sorry, small t is given what? What is the small t? Yes, so it's a t. This is, it's a t. X is equals to 5 sine 2 pi by t is what given ma? 4. And small t value? Small t is given as what? 0.5. And then what is it? 2 ones, 2 2's. Pi by 2. 0.5. 5 by 10. 5 by 10 means what? 1 by 2. 1 by 2 and pi by 2. Pi by 4. Pi by 4 is what? X is equals to 5 into 1 by root 2. It's a 1 by root 2. 1 by root 2 meter. Next one. What is the max? V max. A omega. What is the formula for maximum velocity? A omega. What is A? A is given 5 in centimeter. If it is asking meters, into 10 power minus 2. Omega 2 pi by t is what? It's a 4. Will be your answer. 2 ones, 2 2's. Okay. So pi means like in terms of pi, leave then. Otherwise, pi value substitution means what? According to options, we can answer. Velocity at 3 centimeter. Velocity at 3 centimeter. So velocity at 3 centimeter is what? V is equals to, okay, V is equals to 3 centimeter position omega under root of a square minus x square. What is omega? Omega means what? 2 pi by t. Correct? 2 pi by t. Under root of, what is a given? Amplitude A is what? 5 square minus x square. X is what? What is x given? 3 centimeter. Okay, this is what? 3 square. It's a 2 pi by 4 into pi square 25, 3 square 9, 25 minus 9, 16. Square root of 16 is what? 4. This cancel. What is the answer? 2 pi. Okay, centimeter per second. It's not in meters because it's mentioned in what? The values are mentioned in what? Centimeter. Pi value 3.14. So we can substitute like. Next model question. Question number 2 like based on this. Same thing. If a particle performing SHM, careful on the question. It performing SHM, amplitude given and frequency. So its amplitude is what? 0.01 centimeter. Its amplitude, just you take it about 0.01 centimeter. Frequency is what? 60 hertz. Amplitude is, I am taking about in the meters. Okay. So this is what? 0.01 meter. Yes, A given, and next one is about its frequency. So determine the maximum. So from this condition, determine maximum velocity and maximum acceleration. What is the formula for maximum velocity? Maximum velocity, where the velocity is maximum? At mean position. What is the formula for this? A omega. What is A? 0.01. Omega 2 pi by T means 2 pi F na. Reciprocal of time period is what? Frequency. What do you say this? 0.01 into 2 pi F value 60. Okay, all in SI. Okay, so this is what 2 pi into, what do you get it as? 0 1 get cancelled, 0.6 only na? Correct? 0.6. So 6 to the 12, 1.2 pi is the answer. So what is the maximum acceleration? A max omega square A. Actually it should be what? Plus or minus. So I am taking as just magnitude like omega square A. What is omega? 2 pi F whole square into A. 4 pi square F. F value is what? 60 into 60 into what? A. A is what? 0.01 will be your answer. Okay, according to options. If it is there in terms of pi square, you can substitute. Or if it is not given in terms of pi square value approximately you take it as 10. 3.14 into 3.14, 9.8 like. Okay, so this is 4 into 10, 3600 into 0.01. Okay, so this 0.01 is this cancel. So 40 into what? 36. What's your answer now? 36 into 40. 1440. Okay, meter per second square. Acceleration. Differential equation of SHM is next condition. What is the differential equation of SHM? F is equals to restoring force. What is the formula for restoring force? Restoring force, just now we completed. F is equals to minus kx. F is proportional to minus x. Okay, F is equals to minus kx. Okay, so then this is what? Restoring force. For the acceleration, A is equals to minus omega square x. Just a minute. For this, so restoring force F is equals to F proportional to minus x. F is equals to minus kx. Okay, so this is, from this case I am writing as F means what? MA is equals to minus kx. A is equals to minus k by m into what? X. A is equals to minus omega square into x. Just you know already this one, omega square. K equal to m omega square, we did correct. Okay, then omega square is equals to what? K by m. Okay, so this is acceleration, position of a particle. X gives what? Position. X gives what? Position of particle. Yes. Next one. V gives what? Velocity. V is equals to what? Dx by dt. Correct. V stands for velocity. If you want to write acceleration, A is equals to dv by dt. This also we can write d square x by dt square is the linear form. Now, in place of A, I can write it as d square x by dt square plus omega square x is equals to what? 0 is differential form of SHM. In terms of differentiation, so that's what? D square x by dt square plus omega square x is equals to what? 0. So omega gives what more? What is this one? Angular velocity. It's a angular velocity. Okay. So up to here you can solve some equation will be given you. Anyone some equation. X is equals to a sin omega t. X equal to sin omega t plus cos omega t. X is equals to sin omega t plus 2 cos omega t. Like anyone. Okay, some equation will be given. So which of the following is SHM? Which of the following equations are SHM? Okay, so just I'm giving as this. So some equation. The question is what? Question. Which of the following equations so our functions represent SHM? Say represent SHM. Okay, it represents what? SHM. For the first one, very first one, so I'm talking about this is what? Sin 2 omega t. First question. Okay, second one is about second question. So sin omega t plus 2 cos 2 omega t. Sin omega t plus 2 cos 2 omega t. 2 leave then. Only omega t is going. 2 cos omega t. For third one is about sin omega t plus cos 2 omega t. Which of the following represents SHM? Such a very important things. So sin omega t, first one, which of the following represents SHM means what? SHM means what? A should be proportional to minus x. That's it. Only the condition is what? A is directly proportional to minus x. For first one, this is what? For the first one I am talking on this very first case. Very first one. What is there? Let it be it's x. X is equals to sin 2 omega t. It's a x. You find now v, then you find a. Then if it is satisfying this condition, a is equals to what? A proportional to minus x, it executes what? SHM. Careful on this. So first one, I'm finding about v. V is equals to what? Dx by dt. Then what do you say? D by dt times of x means what? Sin 2 omega t. V is equals to. Okay, differentiation of sin is what? Cos 2 omega t. Cos 2 omega t. Again, differentiation of 2 omega t is what? 2 omega. Correct? So then what? V is equals to, what do you say this is what? V is equals to 2 omega cos 2 omega t is what? Velocity. After getting velocity, you write for acceleration. A is equals to, what is the condition? dv by dt. A is equals to d by dt times of 2 omega cos 2 omega t. Okay, it's a 2 omega cos 2 omega t. A is equals to 2 omega as it is. Differentiation of cos is what? It's a minus sin 2 omega t. Again differentiation of 2 omega t, it's a 2 omega. What do you write now? A is equals to minus 4 omega square sin 2 omega t. Okay, so this we can write about A is equals to minus. So just what? Omega square as it is I am writing this. Okay, minus 4 omega square as it is I am writing. This is what? Sin 2 omega t. Sin 2 omega t. What is sin 2 omega t? It's a x. Okay. So I am writing this is what it's a x. A is proportional to minus x. Something constant into x. A is proportional to minus x. It represents what? SHM is the first one. For all the equations, you can do like this one. For second one, sine omega t plus 2 cos omega t. Okay. So, sine omega t plus 2 cos omega t. Let us do for second question. Okay. X is equals to what we written? Sine omega t, sine omega t plus cos 2 cos omega t, 2 cos omega t. Okay, is the equation. Let us prove now. So try it now. Directly I am doing V. V is equals to differentiation of sine omega t, cos omega t into omega plus 2. Differentiation of cos omega t minus sine omega t into omega. V is equals to, okay, omega cos omega t minus 2 omega sine omega t. Acceleration A. A is equals to, again differentiate omega square, correct? Omega square. Differentiation of cos theta minus sine omega t minus 2 omega again square. Differentiation of sine omega t cos omega t. Okay. So this A is equals to minus omega square times. Then what is this? Sine omega t plus 2 cos omega t. Sine omega t plus 2 cos omega t. What do you write from this? It's a x. A is equals to minus omega square times of x. A is proportional to what? Minus x. It's what represents SHM is the case. Getting? So for the next second question. The second question is what given? Sin omega t plus cos 2 omega t. So third question is what? Like x is equals to sin omega t plus cos 2 omega t. Check it clearly this. Okay. So clearly you can observe this from here. First velocity I am writing this. Velocity means what? Dx by dt. Differentiation sin theta omega cos omega t. Differentiation of omega t is what? Omega. Okay. Plus minus sin 2 omega t into 2 omega. V is equals to omega cos omega t minus 2 omega sin 2 omega t. Acceleration. Okay. Again differentiation. Omega square. Okay. Differentiation of cos omega t minus sin omega t. Next minus differentiation of 2 omega t, 2 omega and 2 omega, 4 omega square sin omega t cos 2 omega t. Correct? So this is what A is equals to omega square minus common. What do you get? Sin omega t plus 4, correct na? 4 cos 2 omega t. Is this x here? You check this one. This is x. Yeah, 4 is there, na? 4 is there, no? So, do you write as a function of x this? No. So, then what? A is, okay? It is not. A is not proportional. proportional to x. Then what do you say? Not SHM. It's not SHM. Okay, this is a very important relation. So the question based on this, like a differential form. Okay, so if a particle executing SHM, with a particle executing SHM, so it's a 16 d square x by dt square plus 25x is equals to 0 is the equation. Some differential equation is given. Okay, so and I'm asking, this is what the question, like particle executing SHM, 16 d square x by dt square plus 25x is equals to 0. First one, find nature of motion. Second, find time period. Like this. Nature of motion means what? Is it executing SHM or not? Okay. So let us see first one. This is what, as we discussed, it's what? Differential equation. Differential equation formula is what, ma? D square x by dt square. Okay. D square x by dt square plus, what is the condition? Omega square x is equals to 0. Isn't it? Yes or no? So this is what? D square x by dt square equal to plus omega square x equal to 0. See, is there any multiple here? For the d square x by dt square, is there any multiple for this? No. But here is some coefficient is there. You need to remove this one. Then what to do from this? Okay. D square x by dt square divided with 16. Okay, then what? Plus 25 by 16 into x is equals to 0. Correct? So now what is omega square? First of all, I mean to know about, what is the nature of this one? It's what? SHM. Correct, na? It's a SHM. Next, for the second one is this. So what is this omega square? Omega square is equals to 25 by 16. Omega square is equals to 25 by 16. Omega is equals to, what you say? 5 by 4. Omega means what? 2 pi by t. 2 pi by t is equals to what? 5 by 4. Okay. So then t is equals to, what you write? T, time period t is equals to 4 to the 8 pi by 5 seconds. Yes, 4 to the 8 pi by 5. So this is what time period, and the motion is what? SHM. Which type of SHM? Linear SHM, we can say like. Okay. For the next class, we will discuss about energy. Energy is kinetic energy, potential energy, total energy, and their equations. Okay.